Hello and welcome to this session of Introduction to Autonomous Systems. As you have been following the various sessions, you would have realized that we have introduced a number of ideas with regard to the artificial intelligence and its various elements and facets that are required in the context of creating intelligent autonomous systems. Having gone through these, let us now look at one important element which relates to the various issues that will come up when we start implementing the artificial intelligence and the complexity arising out of such implementation process. So let us begin, and as we have seen, the creation of AI based agents is essentially a task of development of intelligent rational agents, and the key idea is that all these systems that we are going to develop are capable of human like behavior in practical scenarios. Therefore, it is clear that such agents will also need to have the basic attributes of autonomy, as we have seen, whose provision in the agent architecture also brings in complexity in its implementation. So, let us look at some of those aspects of complexity that we will have to deal with. So, at the topmost level, the complexity comes primarily from providing the autonomic capability or autonomous capability, and it is essentially concerned with the difficulties that we face while making any system autonomous, and at the next level they mainly involve the process of incorporating the 5 attributes of autonomy that we have discussed earlier, that is perception, reflection, planning, goal management and self-correction or self-adaptation. So, those are the 5 attributes of autonomy that ultimately will have to be incorporated in any agent in order for it to become autonomous. It should be realized that we are now currently talking about a fully autonomous systems. Of course, if we look at the complexities in the context of semi-autonomous systems, it will entirely depend upon which of these attributes we are interested in incorporating. So, for example, you could just introduce perception and reflection without others. So, the complexity levels would be lower. But for the sake of discussion, let us look at all possible 5 attributes and how they are going to be incorporated with what level of complexity that they will bring in. So, we will going to talk about complexity of perception, then lack of observability, controllability, which essentially is related to reflection and thereby creating the environment model, complexity of goal management, the complexity of planning and complexity of self-adaptation. So, let us first look at the complexity that is brought in when we are looking at the perception attribute. So, when we look at the complexity of perception, it is primarily related to difficulties faced during interpretation of stimuli and timely generation of the inputs. What we are looking at is the process where sensors which provide a stimulus to the system, how do we interpret their sensor information? Just to give you an example, suppose we have a visual sensor like a camera, a high speed camera which is generating images. Now, images by themselves are just raw data. But from the point of view of providing this information so that a reflection can generate an environment model may require on that image, maybe the image processing, identification of geometric features, identification of objects, putting a tag to the objects, all those would require interpreting that picture. Now, that process would then involve some amount of difficulty in the sense that how does one interpret a picture and what is the information content in the picture that is to be extracted in relation to the environment model building exercise which will have to be taken up next. And an associated issue will come up is that how long would it take to generate those information, because depending upon the level of interpretation of the information, there will be some time required. We will talk about this time issue at a later stage in the course where we will talk about the timeliness of generating all this information. But at this point, let us just accept this basic requirement that there will be a requirement on time that we will have to meet in order to complete this task of perception, and that will bring in the perception complexity. And from where do these sources of difficulty arise? And we realize that the stimuli itself is the major source of difficulty in the form of ambiguity. There could be lack of clarity, there could be, for example, if the vehicle in which we are putting a camera and that is taking a picture of the environment surrounding, if the frames are moving at a fast rate, speed is high, there will be fuzziness in the image which will generate ambiguity in the picture. And that ambiguity could result in multiple interpretation, vagueness, and more importantly, depending upon the number of frames which get generated, let us say in a second or in a minute, the volume of data in the form of number of pictures that need to be processed in the given time frame will generate delays. So, which means the sources of difficulty essentially would be related to multiple interpretations, fuzziness of the data, it could be visual or any other source, like for example, if you are using sonars or lidars, there could be multiple vagueness in the data. The volume of data could be very high, they all lead to delays, and all these will ultimately result in difficulties that arise from our perception process. And as I have mentioned, this type of complexity is also concerned with operational aspects that must happen in real time. We were going to talk about the real time issues and the various requirements that will come up on the system in the form of software and hardware tools that we will need to put together. It will also add complexity to the agent design as well as the agent implementation. Let us now look at a reflection element which is typically in the form of lack of observability and controllability. So, when we look at the basic issue of lack of observability, it typically refers to the partial knowledge of environment, which essentially means that suppose let us say that a picture is rich in color and that the color is important in terms of creating the environment model. We may only have a black and white camera, which means we have already lost the color information. We only have the various gradation in the form of grayscale, and in all such cases the partial knowledge of environment will result in inability to create a faithful runtime model by the reflection module, which means it will not be possible for us to create a faithful picture of our environment because we have lost some part of information because there is no sensor for it, and because there is no sensor for it, we have a problem. This deficiency affects the ability of the system to build plans and act rationally on the environment, which means it will directly go and impact your ability to create good plans. Next, let us look at the complexity of goal management. The complexity of goal management is the complexity of the process to choose from a set of goals a maximal subset of compatible goals for which the plan is to be generated, which means among the process or among the various goals which will have different levels of acceptability, the probability, the quality, the utility, so many things are going to be there. We need to choose a subset which is going to be compatible with our plan and what our objective is, and for which we are going to have to generate a plan. Of course, we should note here that the underlying selection process can become complex because many of the criteria could be qualitative. For example, when we look at priorities, they are purely qualitative, even though there could be some numerical attribute which we may use to prioritize, but most of the time there will be only qualitative information, and there could be also quantitative information that might require an optimization process that is going to bring in its own complexities. It could be a single objective optimization, it could be a single objective with multiple criteria optimization, which could be qualitative, which could be inequality criteria, which could be equality criteria, and then it could also have a multi-objective optimization, which means there could be multiple objectives which may need to be optimized together through a weighted optimization process. You will realize that all these quantitative activities which will involve optimization, as well as qualitative activities which will involve prioritizing the various goals, will bring in definitely a complexity which will make the selection process will become quite complex. Now let us look at the complexity of planning. The complexity arising of planning activity directly depends on now the two earlier complexities that we have looked at, that is the environment model that we are going to create. How complex is that model? Depending upon the scenarios, depending upon the perception, depending upon the reflection process that we have done, there will be a complexity involved in the model itself and the type of goals that we have set for ourselves. If we have set for ourselves tough tasks in the terms of quantitative, where you are going to require a large or very fine accuracy, large precision, all of that will ultimately directly impact in how we are going to carry out our planning activity. This is due to the fact that goals can be simple. They could be as simple as meeting a constraint, saying that don't go beyond this side of the road. For example, suppose let us say that there is a yellow line to the left of the road, and the goal could be that you should never cross that yellow line. So, this could be as simple as that you would simply keep a minimum distance with the yellow line. That could be one of the goals of driving. Or it could be meeting several optimality criteria in terms of distance travelled, in terms of time taken, etc. Or even could be a reachability condition over, which means that over a period of time these are the values of the various states that you must reach. So, it could be a combination of any of these, and all of this will make our planning process reasonably complex. Lastly, let us come to the complexity of self-adaptation, which perhaps is the main element that is going to make our system intelligent, rational, and hence autonomous in the true sense of the word. So, we need to realize that this task of self-adaptation in some way is directly related to uncertainty in the environment model. We can have very good sensors, we could have a very clear cut and very fine perception process, reflection modules, goal management, planning, everything. But the uncertainty that is left, because no matter how good our perception is, how good our reflection is, finally there will be some amount of ambiguity or uncertainty in the environment model that we will create, and which will mean that any action that we will take, its impact on the model is unpredictable. Which means if we think that if we give this much of our accelerator input, in this much of time we will reach the next intersection. It may not happen. So, you will need to adapt, and this is what will bring in some amount of complexity in the process of self-adaptation. The common sources, if we look at, are time varying loads. For example, there could be winds which are changing and that will create variable drag on it, and it will, even if you are given acceleration or accelerator, speed may not increase to that level. Dynamic changes which are going to occur due to mobility, sudden and critical events like suddenly you encounter a pothole, so you have to break down. There could be failures which might occur in some, for suppose let us say suddenly you are seeing a signal and suddenly signal stops working for whatever reason, you have a problem. So, all these will now bring in complexity in our ability to adapt to a changing scenario, and generally we find that reduced or partial observability also will create a problem in the form of uncertainty, and that will also add, which means if there are some sensors which do not exist and that information is not available, we will have a problem. So, to wrap up this part and conclude, we can say that autonomic complexity is an important aspect of creating intelligent rational systems that have human-like responses, and we will need to consider all these aspects in the step of implementation of our agent design that ultimately we are going to convert into a physical hardware and a realized product. So, with that we come to the end of this session. We will continue some of these ideas in the subsequent sections. So, bye for now and see you in the next session.